So we start this problem by saying that let the length and breadth of the rectangular part be L and B. And B. Okay. So let's label it here. Now try to understand. Okay. These problems are mostly of understanding. Differentiation is not the difficult part. Maxima minima is not the difficult part. Try to understand why I am defining which one as which, and why I am treating which one as variable and which one as constant. Okay. So this is your length and breadth. So here, what should be L and B? L and B are variables. We need to find such the value of length and breadth L and B that the area of this window is maximum. That is, it allows maximum possible amount of light. Okay. Now L and B are variables. Now see, if this is L, then what should be the radius of the semicircle? L by 2, right? This is the radius of the semicircle. Therefore, what is the um, perimeter of the semicircular part? Let's say perimeter of the rectangle first. Perimeter of the rectangle twice L plus B, right? Next, perimeter of the semicircular part. Semicircular arc CD is equal to 2 pi r. R here is L by 2 and divided by 2 because because it is semicircle, which gives you pi L by 2. Okay. This is the perimeter of the semicircular arc. So what is the perimeter of the figure? Perimeter of the window. Perimeter of the window is twice. Okay, perimeter of the rectangle, I have included the part CD. So perimeter of this should be rectangular part. Because we are not including this side CD, right? So therefore, it should be AB plus twice BC. AB is L plus twice B. Okay. This is the perimeter of the rectangular part. So what is the total perimeter? L plus 2B plus pi L by 2. I hope you understood what I did, right, with the perimeter. Okay. So this is the perimeter of the semicircular window. So how much is this given? Therefore, L plus 2B, perimeter of the window is given to be 30, right? Okay. So this is, call this 1. Now this relation is very important because later on, the function that we are going to find, which we want to maximize or minimize, this function will be helpful in reducing the number of variables of that function. Okay. Now, see the question. Question is, find the dimensions of the dimension so that the greatest possible amount of light may be admitted. When the greatest possible amount of light will be admitted? The greatest possible amount of light is admitted when the area of the window is maximum possible. That means we have to maximize the area of the window. So let's first find out the area expression for the area. What is the area of the window? Area of the window A is equal to first area of the rectangular part. What is the area of the rectangular part? Length into breadth plus area of the semicircular part. What is the area of the semicircular part? Pi r square. R is L by 2 divided by 2. Right? Can write this as LB plus pi L square divided by 8. Right? Now this is number 2. We need to maximize this function. But the problem is there are two variables. You see how many variables are there? L and B, right? These two are the variables. So how can you maximize the function with two variables? You cannot. So therefore, with the help of one, we reduce the number of variables here. So what do you do? From 1, you find out the value of B. From 1, L plus 2B plus pi L by 2 is equal to 30. You find out the value of B from here. You get 2B is equal to 30 minus pi L by 2 minus L. Right? That means what is B here? B is equal to half 30 minus L minus pi L by 2. Now what you do, since you have found out the value of B, from here, the value of B, you put it here. That so that the expression for area will be reduced to only a single variable. Putting this value in 2 above, we get A is equal to L. Value is, put the value half 30 minus L minus pi L by 2 plus pi L square by 8. Yes. So now if you see the expression of area contains only one variable, and that is L, right? So now let's simplify this expression a little and then we'll differentiate. It is actually ready to differentiate, but we want to simplify this so that our differentiation becomes a little easy. You multiply everything with L by 2, you get 15L minus L square by 2 minus pi L square by 4 plus pi L square by 8. That means A is equal to 15L minus L square by 2. And if you take the LCM between pi L square by 4 and pi L square by 8, you will get minus pi L square by 8. Okay. Now it is ready to differentiate. So we need to maximize A. Okay. How do you maximize A? First find out the first derivative, dAdl. dAdl is 15 minus L square by 2. Take half out. DDL of L square is 2L. Minus take pi by 8 out. DDL of L square is 2L. You understood this differentiation or any question you have? Okay, so this cancels. So
Okay, sir.
you get 15 minus L minus pi L by 4. This is what you get after differentiating. Okay. Now for maximum or minimum A, what is the condition? A, we have dAdl is equal to 0. That means 15 minus L minus pi L by 4 must be equal to 0. You find out the value of L from here. You get L plus pi L by 4 is equal to 15. It means L into 1 plus pi by 4 is equal to 15. That means L is equal to 15 by 1 plus pi by 4. Now if you take the LCM in the denominator, you will get 60 by pi plus 4. Okay, at this length, area is either maximum or minimum. Now, how do you check whether the area is maximum or minimum? Find out the second derivative, d2a dl2. Now, which function do you have to differentiate? You differentiate this function, right? To find out d2a dl2. So what should be? 0 minus ddl of L is 1 minus pi by 4 is a constant, take it out. ddl of L is 1. So what is this? This is negative, right? Uh, beside, don't write negative positive now because we are going to test it at the given value. So this is minus 1 minus pi by 4. This is actually a constant d2a dl2. So at that value, at L is equal to 60 by pi plus 4. What is the sign? d2a dl2 will remain the same because it's a constant function. It's negative, right? So thus what can I say? Thus A has a point of local maximum. At what point? L is equal to 60 by pi plus 4, right? So length you have got for maximum area. What is the length? 60 by pi plus 4. What should be the breadth? We can find the breadth from this number 1 here. We can find it from here, right? From 1 you can find out, from 1 I found out the value of B. You can find out B from here. So at L is equal to 60 by pi plus 4. Okay, B should be equal to 15 minus L by 2 minus pi L by 4. This is what we had got from 1, right? Which is equal to, put the value here, this is B, right? No, this is DADL. This is not B. This is not B. B was, yeah, this one was B. Half 30 minus L minus pi L by 2. This was B, right? So that put it a value here, half of 30 minus L is 60 by pi plus 4 minus pi by 2 times L, 60 by pi plus 4. Okay, so you get here, can cancel this. You get here half 30 minus 60 by pi plus 4 minus 30 pi by pi plus 4. Now you take the LCM, half pi plus 4. So you get 30 into pi plus 4 minus 60 minus 30 pi. So you get half 30 pi plus 120 minus 60 minus 30 pi divided by pi plus 4. So if you see 30 pi and 30 pi, they cancel. So what you get here is half of 60 by pi plus 4. So you get here 30 by pi plus 4. So that is the breadth. So for uh, greatest possible amount of light, to be admitted through the window, that is when area is maximum, when area A of the window is maximum, length L is equal to 60 by pi plus 4 found above. And what is the breadth B? 30 by pi plus 4. Clear with this problem or any question? Now these problems are a little long, okay, but they are not, once you are able to distinguish between constant and variable, it is not that difficult. Is it clear with this problem or any question you have so that I can proceed to the next problem then?
No.
Okay, then I can proceed to the next one.
Yes, sir.
Now on Monday, I'll be taking a test on maxima and minima. Okay, I have not
Okay, sir.
included applied problems. So 25 marks test on Monday, same time, 1:30 to 2:10. I'll give you the test schedule today itself and the syllabus and the sample paper. Okay, let's see number 6. I won't do because 6 is very similar to one problem here, number 9. 6 and 9 are very similar. So you can work number 6 on your own. I'll start number 7. Number 6 and number 9. These two problems. These are very, very similar. Exact working of whatever working you require in 6, you would require in 9 also. Okay. So I'll show you 9. You can do 6 on your own. Number 7. Question is, show that of all rectangles inscribed in a given circle, the square has maximum area. Okay, so let's draw a circle. And inside the circle, you draw a rectangle. Let's call this rectangle ABCD. Let us call O as the center of the circle. So now we'll see what is given to us here. Okay, that is the main thing in maximum minimum. Identifying what is given. That is given will be always your constants and the others will be your variables. Okay, what you are defining. Show that all circles inscribed in a given circle. Given circle means obviously radius of the circle has to be given, right? So I say let the radius of the circle be A, the given circle. So here A is a constant because the circle is given to you. Okay, so this length, we try to join this. So this length will be your A, and this length will also be your A. So therefore, OA is equal to OC is equal to A, right? So therefore, what is the length of AC? 2A. Okay, now once we have defined the radius, now we define the sides of the rectangle. So let the length and breadth. Now you need to show that this rectangle is a square. This rectangle has maximum area and it is a square. So how do you show it is a square? You just show length is equal to breadth, and if length is equal to breadth, then it is a square. So first I define, let the length and breadth of the rectangle be A. Of the rectangle ABCD be L and B respectively. So here L and B are what? Here L and B are variables, right? So this part is your L and this part is your B, right? So now from Pythagoras theorem, if you apply Pythagoras theorem in this rectangle, what will happen? In triangle ABC, AC square is equal to AB square plus BC square. This will give us a relation between L and B. Why should I get a relation between L and B? Because you see L and B are both variables. Now if I get a relation between L and B, then later on when I am defining the function which needs to be maximized or minimized, in this case maximized, because they are talking about maximum area, then what can I do? From two variables L and B, I can come down to a single variable, either L or B. Okay, you understand that this fundamental here. 2A square is equal to L square plus B square. That means you get 4A square is equal to L square plus B square. Okay, so call this 1. We have got a relation between A and B, L and B, sorry. We have got a relation between L and B. This L and B will help us later on to reduce the number of variables. There are two variables, L and B, right? So we need to bring it down to a single variable in order to maximize or minimize. Now, what needs to be maximized here? Area needs to be maximized. So let us find out the area of the rectangle. What is the area of the rectangle?
AB.
LB.
LB. Sorry.
Area of the rectangle A is equal to LB. Now we need to maximize this area, right? But area contains how many variables? Two
2.
variables. Now we need to bring down to one variable. Which one will help us bring down to one variable? Number 1. Equation number 1 will help us bring this down to a single variable. So from 1, what can you write? From 1, you have L square plus B square is equal to 4A square, right? That means you can find out the value of B from here. B square is equal to 4A square minus L square. That means B is equal to root over of 4A square minus L square. Putting this value, call this 2. Putting this value in 2 above, we get A is equal to L and B is root over of 4A square minus L square. Now is it down to a single variable? Yes. If you see A is only in terms of a single variable L. Now we are in a position to maximize or minimize A. So we need to maximize A. Okay. First find out the first derivative, dA dL. dA dL will be how much? Differentiate this by U into V rule. root over of 4a square minus L square into DDL of L, which is 1, right? Plus, now treat L as the function which you don't need to differentiate. The other function that you need to differentiate is root over of 4a square minus L square. And what is the differentiation of root over of 4a square minus L square? First differentiate the radical. So you'll get 1 by 2 root 4a square minus L square into the DDL of 4a square minus L square. What is the DDL of 4a square minus L square? 0 minus 2L, right? So you get here root over of 4a square minus L square, and you get up because there is a minus sign here. Okay, let's write it first in this manner only. Then we'll see what we can do with the minus sign. Into minus 2L. So you see this 2 and this 2 will cancel. So you get root over of 4a square minus L square minus L square by root 4a square minus L square. Okay, this is your, and we can take the LCM and simplify it a little further. 4a square minus L square. So you get 4a square minus L square, and you get here minus L square. So what you're getting here is 4a square minus 2L square divided by root over of 4a square minus L square. This is equal to, and you can take 2 common to get 2a square minus L square divided by root over of 4a square minus L square. So DADL we have found. So for maximum or minimum area, area A, DADL must vanish. Then what is the value of DADL? Twice 2a square minus L square divided by root 4a square minus L square is equal to 0. That means you get twice 2a square minus L square is equal to 0. That means 2a square minus L square is equal to 0. That means L square is equal to 2a square. That means L is equal to a root 2. Okay. So when length is equal to a root 2, area is either maximum, area of the rectangle is either maximum or minimum. Okay.